Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 7th question from the worksheet I've prepared for chemical equilibrium. Please do expect a total number of 8 videos since the worksheet guys has 8 questions in total. And please do note that all of these questions are extracted from past exam question papers. So it's very important for you to know how to tackle such questions. I strongly believe that it will give you an edge whenever you write your final examination. So please guys, do share the video to your peers so that they may have the same edge as you, and please do help us grow the channel by just subscribing. Okay, we are being asked to consider the balanced equation for the reversible reaction. Okay, on our reversible reaction guys, we have nitrogen which will react with oxygen to form nitrogen monoxide. Okay, first question, what is meant by the term reversible reaction? A reversible reaction, guys, is just a reaction whereby your products can be converted to form reactants again. It's a reaction such that products can be converted to form reactants. Okay, the sketch graph below shows the relationship between the value of the equilibrium constant for the reaction and the temperature. Okay, I can see that guys, as temperature increases, the equilibrium constant also increases. Are we together? So basically, as temperature increases, we are forming more products because Kc will increase if and only if our yield increases. Are you together? So that will only happen if and only if the forward reaction is endothermic. Are you together? An endothermic reaction is a reaction that absorbs heat for it to form products. Né? That means heat is on the side of reactants because these, for these two to react and form products, they need to have external energy. Are you together? Endothermic reaction, guys, simply means you just have a non-spontaneous reaction. Are you together? And obviously, for a non-spontaneous reaction to form products, you will definitely need temperature. Okay, first question we are being asked, is the reaction endothermic or exothermic? The reaction is endothermic. The forward reaction is endothermic. Are you together? Why do I say so? Okay, as firstly guys, as temperature increases, that's point number one. Yeah? As temperature increases, I can see that the equilibrium constant also increase. Are you together? And for point number two, I know that equilibrium constant will only increase if ever the yield is increased. Are you together? And for me to increase the yield in point number three, I'll simply say the forward reaction is favored. Are you together? But remember that guys, whenever you increase temperature, you will always favor an endothermic reaction. So since the forward reaction is favored, you can therefore conclude that your forward reaction is endothermic. That's how guys we're supposed to explain there in 6.1.3 rather. Okay, and then now we are being asked, how will each of the following changes affect the amount of nitrogen monoxide at equilibrium? Choose increase, decrease, or remain the same. Okay, more nitrogen gas is added. For us guys to answer these questions, we need to apply Le Chatelier's principle. Le Chatelier's principle, guys, simply says that whenever equilibrium is disturbed in a closed system, the system will shift in such a way that it will favor the side, or rather, it will favor the reaction that will oppose the change. Are you together? Whenever equilibrium is disturbed, the system will shift in such a way that it will favor the side, or rather the reaction that will oppose the change. So in this case, guys, if ever I'm increasing on nitrogen, the system would want to create balance. How can it create balance? By simply decreasing nitrogen. The only way to decrease nitrogen is if we favor the forward reaction, guys. is if we favor the forward reaction by just using this nitrogen. But obviously, guys, for us to form nitrogen monoxide, we need both nitrogen and oxygen. So if nitrogen will decrease, that means oxygen will also decrease. However, our nitrogen monoxide will just increase because the forward reaction is favored. So over here, for 6.1.4, the answer is just increase. Okay, and then for 6.1.5, they tell us that the pressure is increased by decreasing the volume. Whenever, guys, we tamper with pressure, for example, if ever we increase pressure, we will always favor the side with the least number of gas moles. Are you together? How can we calculate gas moles? Just check your stoichiometric coefficients of your gases. Over here, I have my nitrogen is a gas as well as my oxygen. However, the stoichiometric coefficients, I just have 1 and 1 over there. So in total, I have 2. I have 2 moles of gases. Are you together? And then on the right hand side, my nitrogen monoxide is a gas, and then the coefficient, or rather the stoichiometric coefficient is 2. So I have equal number of gases in both the left hand side and the right hand side. So over here, guys, an increase in pressure will never change my yield, or rather it will never change my nitrogen monoxide. Are you together? Whether I increase pressure or decrease pressure, that thing will never tamper with my yield. So over here, I'll simply say this will remain the same. Remain the same. Okay. 6.2, we are told that initially 336 grams of titanium and 426 grams of chlorine gas are mixed in a sealed 2 cubic decimeter container at a certain temperature. The reaction reaches equilibrium according to the following balanced equation. Okay. At equilibrium, it is found that 288 grams of titanium is left in the container. The first question, guys, they want us to calculate the equilibrium constant. Okay, for us, guys, to find equilibrium constant, there are certain things we need to do first. We have titanium that will react with chlorine, and then will form titanium chloride. Titanium chloride, okay. We have initial moles, the change in moles, moles at equilibrium, as well as the equilibrium concentration. So it's initial moles, the change in moles, moles at equilibrium, and then equilibrium concentration. Okay, since, guys, we are given the mass, all we have to do, guys, is to change that mass that we are given and change it into number of moles. So the initial number of moles of our titanium, number of moles of titanium initially, it's just mass divided by the molar mass. The mass of titanium, we were given 336 grams. The molar mass for titanium, guys, it's found at the back of your question paper. There's a periodic table. The molar mass is just 48. So I simply say 336 divided by 48. This will just give me 7 moles. So I know that the initial number of moles of my titanium is just 7 moles. Let's go and find the initial number of moles of our chlorine gas. The number of moles of chlorine initially, I simply have mass divided by the molar mass as well. The mass that I was given is just 426. Molar mass for chlorine is just 35.5, but I have 2 of them. So I'm just going to multiply it by 2. 426 divided by 35.5 times 2. This will just give me 6 moles. So initially I had 6 moles of chlorine, but at the beginning of the reaction, guys, I did not have any amount of products. So over here I'll simply have 0 moles of my titanium chloride. Okay, and then I was also told that at equilibrium, I'll be left with 288 grams of titanium. At equilibrium, the number of moles of titanium at equilibrium, it's the mass at equilibrium divided by the molar mass. That's basically 288 divided by 48. 288 divided by 48. This will just give me 6 moles. Okay, so at equilibrium, guys, my titanium is just 6 moles. At equilibrium is 6 moles, right? For me, guys, to be able to find the equilibrium constant, the first thing I need to do is to find the amount of moles that have reacted, or the amount of moles that have that were produced, and then simply go and find the equilibrium constant. So let's just fill in our table now. Initially, guys, I had 7 moles of my titanium, but at the end of a reaction, I'm left with 200, I'm left with 6 moles of titanium. That means I've only used 1 mole of titanium. Are we together? Okay. I know that, guys, I'll just need 1 mole of titanium to react it to 2 moles of chlorine gas for me to form products. But now, guys, I only have 1 mole of titanium. I want to know how many moles of chlorine will I need to react this 1 mole with. Ne? Just cross multiply. 2 multiplied by 1 is just 2. Then 1 multiplied by x is just x. So I'll simply need 2 moles of chlorine. X represent the number of moles of the chlorine that will react with titanium. Basically, it's just 2 moles. So that's 2 moles over there. Ne? I don't need to fill in the table over there, guys, because for me to find Kc, I'm going to use chlorine because it's the only compound that is allowed to be in the Kc expression. Why? Because whenever you calculate Kc, we do not include solids and liquids. Ne? But just for the sake of not forgetting how to fill in the table, I'll just do it for you guys. Ne? Okay, let's do the same thing, guys, for titanium chloride. That's Ti. 1 mole of titanium will produce 1 mole of titanium chloride over there. Ne? So since the ratio is just 1:1, so that means the number of moles of our products, the number of moles that will be formed of products will simply be the number of moles of titanium that will be used. Since the ratio is just 1:1, ne? So I'll simply have 1 over there. But remember that, guys, I am using my reactants to form products. That means my reactants needs to decrease, but products needs to be needs to increase. Excuse me. Okay. Initially, I had 6 moles of chlorine, but I've used 2 moles. That means I'll be left with 4 moles over there. Are you together? Initially, I had 0 moles of my product, but as the reaction progressed, before it reached equilibrium, I produced 1 mole. That means at equilibrium, I'll simply have 1 mole again. Are you together? Since, guys, I cannot find the concentration for solids, I'll only find the concentration for my chlorine over there. I was told that the volume is just 2 cubic decimeters, so therefore the concentration is just 4 divided by 2, which is just 2 moles per cubic decimeter, and hence the Kc is just the concentration of products divided by the concentration of reactants. Are you together? Since my product, guys, is a solid, I'll just write 1 at the top, and then at the bottom I'll simply take my chlorine gas and then to the power 2. Why? Because the stoichiometric coefficient was 2 over there. So this is just 1 all over 2 squared. That's 1 over 4. That's 0.25. So the equilibrium constant over there, equilibrium constant is just 0.25. The equilibrium constant is just 0.25. Okay. More titanium is now added to the equilibrium mixture. How will this change affect the yield of titanium chloride? Choose increase, decrease, or remain the same. Remember that, guys, the factors that can affect equilibrium, we have concentration, temperature, and pressure. Are you together? So if ever, guys, if ever we increase the quantity, we are basically increasing the concentration. But since we cannot find the concentration of a solid, by just increasing the quantity of our solid, we are doing nothing to our equilibrium position. Are you together? And hence the yield will also not change. So this guy over here will just remain the same. That's how, guys, we're supposed to tackle this question over there. So please do stay tuned and wait for more videos. Thank you.